In this video, we will talk about the fundamental trigonometric identities. A trigonometric identity is an equation that contains trigonometric functions, and it is true for every value of the variables that can be used in the equation. There are many trigonometric identities, and in this video, we will talk about the fundamental trigonometric identities. These are the basic trigonometric identities, and they include the reciprocal identities, the quotient identities, the Pythagorean identities, and the cofunction identities. So let's start by discussing the reciprocal identities. For this, let's review the 6 trigonometric functions. Here we have a right triangle with the sides A, B, and C, and the acute angle theta. To find sine of angle theta, we divide the opposite side by the hypotenuse, and that is A over C. Now to the right, we have the cosecant function, and the cosecant function is the reciprocal of sine, and if sine is A over C, cosecant is C over A. So again, these two functions are reciprocals of each other. And now the first two reciprocal identities are sine of theta equals 1 over cosecant of theta, and cosecant of theta equals 1 over sine of theta. I will write the first identity to the right, and this is sine of theta equals 1 over cosecant of theta. And now let's replace cosecant of theta with C over A. Then we will have 1 over C over A. We can also write this expression as 1 divided by C over A. And now we know that dividing by a fraction is the same as multiplying by the reciprocal of that fraction. Then the result will be A over C. So sine by definition is A over C, and if we replaced it with 1 over cosecant, we still got A over C. The next trigonometric function in this table is cosine of theta. By definition, cosine of theta is the adjacent side divided by hypotenuse. That is B divided by C. To the right, we have the secant function, and secant is the reciprocal of cosine. So if cosine is B over C, secant is C over B. Then the next reciprocal identities are cosine of theta is 1 over secant of theta, and secant of theta is 1 over cosine of theta. Let's write cosine of theta equals 1 over secant of theta. And let's replace secant of theta with C over B. This is equal to 1 multiplied by B over C, which equals B over C. So in the table above, cosine of theta is B over C, and if we replace cosine of theta with 1 over secant of theta, we still get B over C. Now, the next trigonometric function in the table above is tangent of theta. By definition, tangent of theta is the opposite side divided by the adjacent side. So tangent of theta is A over B. To the right we have cotangent of theta, and this is the reciprocal of tangent of theta. So if tangent is A over B, cotangent is B over A. And now down here we have the last two reciprocal identities, and one of them is tangent of theta equals 1 over cotangent of theta, and the other one is cotangent of theta equals 1 over tangent of theta. And now to the right, let's verify that tangent of theta equals 1 over cotangent of theta. From the table above, cotangent of theta is B over A, so we will write this as 1 over B over A. Then this equals to 1 times A over B, which equals A over B. And indeed, in the table above, tangent is A over B. Now let's move to the next group of trigonometric identities. These are the quotient identities, and the first one is tangent of theta equals sine of theta over cosine of theta, and the second one is cotangent of theta equals cosine of theta over sine of theta. Now, let's take a closer look at the first one. We know that tangent, by definition, is A over B. This identity tells us that tangent is sine over cosine. Now, I will write this identity to the right, so tangent of theta equals sine of theta over cosine of theta. And from the table above, sine of theta is A over C, and cosine of theta is B over C. Then if we replace, we get A over C divided by B over C. We can also write this as A over C divided by B over C. And now we will flip the second fraction and we will multiply, and we will have A over C multiplied by C over B. Then here C and C will cancel, and we will get A over B. And indeed, tangent of theta equals A over B. Now, let's take a look at the second quotient identity. Cotangent of theta is cosine of theta over sine of theta, and we know that cotangent of theta, by definition, is B over A. Let's write this identity to the right, and then we will verify it. So cotangent of theta equals cosine of theta over sine of theta. Now we will replace cosine of theta with B over C and sine of theta with A over C. So we will have B over C divided by A over C. Or this is B over C divided by A over C. Now let's flip the second fraction and have B over C times C over A. Then C and C will cancel, and the result will be B over A. And this is the value of cotangent. So from these two identities, we need to remember that we can write tangent as sine over cosine, and we can write cotangent as cosine over sine. The next group of trigonometric identities we will discuss here will be the Pythagorean identities. The first one is sine squared of theta plus cosine squared of theta equals 1. Now, let me show you how we can verify that this identity is true. First, let's write it to the right. So we have sine squared of theta plus cosine squared of theta equals 1. Now, this notation of sine squared of theta means that we take sine of theta and we square it. So we can write it as sine of theta all squared. The same we can do with cosine squared of theta. We can write it as cosine of theta all squared. And all this has to be equal to 1. Now let's replace sine of theta with A over C and cosine of theta with B over C. Then we will have A over C squared plus B over C squared. All this equals 1. Then we will have A squared over C squared plus B squared over C squared equals 1. And if we add these two fractions, we will have A squared plus B squared over C squared equals 1. Now, in the triangle above, the Pythagorean theorem states that A squared plus B squared equals C squared. So here we have it, A squared plus B squared equals C squared, and now let's replace A squared plus B squared with C squared. Then in the numerator we will have C squared, and in the denominator we also have C squared. Then C squared divided by C squared is indeed equal to 1. So we just showed that sine squared of theta plus cosine squared of theta equals 1. The second Pythagorean identity is 1 plus tangent squared of theta equals secant squared of theta. We can verify this identity the same way we verified the first one. So let's write that 1 plus tangent squared of theta equals secant squared of theta. And because tangent is a over b and secant is c over b, in the next row we will have 1 plus a over b squared equals c over b squared. Then if we raise each fraction to the second power, we will have 1 plus a squared over b squared equals c squared over b squared. Now let's move this fraction to the right. Then we will have that 1 equals c squared over b squared minus a squared over b squared. And if we subtract these two fractions, we will get c squared minus a squared over b squared. Now we know that the Pythagorean theorem is a squared plus b squared equals c squared. And if we subtract a squared on both sides, then we will get that b squared equals c squared minus a squared. Now in this expression, we can replace c squared minus a squared with b squared. Then we will have that 1 equals b squared over b squared. And b squared divided by b squared is indeed equal to 1. So we just verified that 1 plus tangent squared of theta equals secant squared of theta. And now the last Pythagorean identity is 1 plus cotangent squared of theta equals cosecant squared of theta. Let's verify this one as well. So we have that 1 plus cotangent squared of theta equals cosecant squared of theta. And from above, cotangent of theta is b over a and cosecant of theta is c over a. Then we will have 1 plus b over a all squared equals c over a all squared. Then 1 plus b squared over a squared equals c squared over a squared. From here we will move this fraction to the right and we will have that 1 equals c squared over a squared minus b squared over a squared. Then let's subtract the fractions and have c squared minus b squared over a squared. Now again we will use the Pythagorean theorem a squared plus b squared equals c squared, and we will solve it for a squared. So if we subtract b squared on both sides, we will get that a squared equals c squared minus b squared. Now in this expression, we will replace c squared minus b squared with a squared. Then we will have 1 equals a squared over a squared. And a squared divided by a squared equals 1. So then we can say that 1 plus cotangent squared of theta equals cosecant squared of theta. And now let's see the last group of trigonometric identities, and these will be cofunction identities. To the right we have a right triangle, and we know that in any triangle the sum of all three angles equals 180 degrees. In this triangle, if one angle is already 90 degrees, then the sum of these two angles is also equal to 90 degrees. For example, if this angle measures 30 degrees, then the other angle will measure 60 degrees. And if this angle measures 40 degrees, then this one will measure 50 degrees. Then we can say that if this angle measures theta degrees, then the other angle will measure 90 degrees minus theta. Now, the first cofunction identity states that sine of 90 degrees minus theta equals cosine of theta. Now, let's use the triangle to the right and find sine of 90 degrees minus theta. So here we have the angle of 90 degrees minus theta, and this is the opposite side of this angle. Then sine of this angle, by definition, is the opposite side divided by hypotenuse, and this is b divided by c. Now let's find cosine of angle theta. So here we have angle theta, and by definition, cosine is the adjacent side divided by hypotenuse. Then cosine of theta is b over c. Now, do you see how for both functions we got the same value of b over c? So then, indeed, sine of 90 degrees minus theta equals cosine of theta. Then we call these two trigonometric functions cofunctions. To the right, we have another identity, and that is cosine of 90 degrees minus theta equals sine of theta. Then below, we have tangent of 90 degrees minus theta equals cotangent of theta, and cotangent of 90 degrees minus theta equals tangent of theta. So these two are another pair of cofunctions. And in the last row, we have secant of 90 degrees minus theta equals cosecant of theta, and cosecant of 90 degrees minus theta equals secant of theta. These two are another pair of cofunctions. Each of these cofunction identities can be proved the same way we proved the first one. For example, tangent of 90 degrees minus theta from the triangle to the right is the opposite side divided by the adjacent side, and that is b over a. On the other hand, cotangent of theta is the adjacent side divided by the opposite side, and that is also b over a. Here we are done with the fundamental trigonometric identities. I hope you enjoyed the video. Please subscribe, leave a comment, and thank you for watching.